All right, let's focus for a few minutes here, please. All right, the first two, we're converting from degrees to radians. Okay? So, remember our fraction for degrees to radians is pi over 180, right? So what I would do is just make a longer fraction bar and make it look like that. And then, again, I know that I can cancel the zeros. So I'm just reducing 3/18, and 3 goes into 3 once, and 3 goes into 18 6 times. So it's 1 pi over 6 or just pi over 6. Okay? That's all I got to do. Number 2. Same thing, we got 420. All right, so just make your bar. Put pi next to the 420 over 180. Again, the zeros cancel. And 6 goes into 42 7 times. And 6 goes into 18 3 times. So there's that. And again, you could do that on your calculator and then hit math fraction. You don't put the pi in though. Right? Just leave pi as part of your answer. Okay? So if you do 420 divided by 180, right, Edwards? Okay? And then hit math and enter twice. It'll give you that 7/3 fraction. Okay? So I don't want to see the 2.3 repeating pi. Okay? I'd rather see 7 pi over 3. Okay? Don't multiply those together by the pi and give me the decimal answer. I want it. That's the normal way to see radians. Okay? 3 and 4, we're going the other way. Radians 2 degrees, so we multiply by 180 over pi. So I do the same thing for those that I just did for 1 and 2. So for some reason I had this, you guys should know this answer because we just did it, but just extend it and put 180 over pi, and then again, the pi's cancel. Morning, Daniel. Thanks. Okay, now, me again, I try not to use my calculator as much as possible. So I know 3 goes into 3 once, and 3 goes into 180 60 times. And then I know 7 times 6 is 42, so 7 times 60 would be 420. But if you want to use your calculator, that's fine. Just go 7 times 180, and then divide it by 3. And you get your 420. Okay? Then number 4, do the same thing. And this time I have pi over 5. So I do times 180 over pi. All right. And then just divide 5 into 180. Or, if you can do it in your head, 5 goes into 18 3 times, and 5 goes into 30 6 times. 36 degrees. If you want to do it without using your calculator. Any questions on the first floor? Should we miss any of them? No, we shouldn't. Okay. Simple, right? Okay, number 5. We have a picture of a right triangle. And theta's here. And I gave you this leg and the hypotenuse. Okay? So I have to find the length of the missing leg, the one we don't know, before I can find the 6 tree ratios, right? So I do, I always call this one A and that one B. It doesn't matter though. So A squared plus B squared equals C squared, Pythagorean. So 25, 64, subtract the 25, and B squared is what's that, 39? And then take the square root, right? So this is the square root of 39. That doesn't reduce down to anything more simple. Don't give me the decimal. Don't give me the 6.2 or whatever it is. Okay? Leave it in radical form. So then we're going to go sine of theta. Remember, it's SOHCAHTOA, right? Sine is opposite over hypotenuse. Ca is for cosine is adjacent over hypotenuse. TOA is for tangent is opposite over adjacent. All right, so theta's here. So opposite of theta is the 5. Hypotenuse is the 8. Cosine adjacent, square root of 39, over hypotenuse, 8. Tangent, TOA, opposite 5 over adjacent, square root of 39. Am I allowed to leave it like that? No, you have to rationalize it. So you have to do the radical 39 over the radical 39. So that's 5 times the square root of 39. And when you have 239, whatever, since they're the same and it's a square root, it just gets rid of that square root, right? So there's the first 3. The other 3 are the reciprocals of those. Okay? So the reciprocal of sine is called cosecant. We use CSC for that and just flip it. So that's 8 over 5. For cosine, it's secant. So I'm going to flip that, and then I have to rationalize it so it becomes this, right? It's going to be just like the 5 over the 39, but it's 8. And you're going to do the radical 39 over radical 39 to get just to be 39 in the bottom. And then cotangent of theta is the reciprocal of tangent. So just do that original. Radical 39 was the bottom, so put it up top. 5 was the top, so put it in the bottom. So there's the 6 answers I'm looking for. I want it in radical form. I want it simplest radical form. Okay, simplify the radical if you can. Okay, if when you do this tomorrow and, all 3 of these are multiple of 3, then divide by 3, make them smaller. That's okay. If they're all even numbers, divide them all by 2, make them smaller so you don't have as big a number to work with. Do it before you have to reduce them. But radicals, make sure they're in the simplest radical form. Any questions on number 5, that type of problem? It'll be just like this. I'll give you 2 of the 3 sides. You gotta find the third side, and then write your 6 fractions. Okay, Sturmy? All right. 6, 7, and 8. I only have asking for 1, all right? And I give you 1 picture you have to look at. So first of all, let's do this. Do our picture. Okay, the information you're given is that the cosine of theta is 2/3. So that's what I'll do tomorrow. I'll give you a trig function equals some fraction. So you draw the picture of your triangle that goes with it. Again, I always like to do it this way, but you know, if you want to put theta up there, it doesn't matter. Okay. Now remember, cosine is ca, right? Adjacent, so 2 over hypotenuse 3. Get that? That's the adjacent side. This is the A. This is the H. Right? That's why I put them in that spot. Okay. So I got to do Pythagorean again to get this side, this leg opposite the theta side there, or the theta angle side. So A squared plus 2 squared equals 3 squared. So A squared plus 4 equals 9. Subtract 4, A squared is 5. And then remember, you got to take the square root. So this is the square root of 5. So there's my 3 sides. Just leave it like that. Don't give me 2.1 or whatever it is. 2.2. Okay? Leave it in radical form. So, for number 6, I'm doing the sine of theta. Morning, Brooke.
Morning.
So again, I'm just looking at my picture. Remember, sine is so, right? So opposite, square root of 5 over hypotenuse 3. That's the answer. Okay. Number 7, I want to keep that picture there so I can do it. All right, this time I'm looking for secant. Okay, secant, which one is it reciprocal of? Sine, cosine, or tangent? Cosine, right? All right, so the cosine's right here, what they gave us, right? So just flip that, 3 over 2. And cosine 2 over 3, so hypotenuse over adjacent, 3 over 2. All right? Number 8, we're looking at the same picture. This time it's tangent of theta. Tangent is TOA, remember? Right? So O for opposite, square root of 5 over A adjacent 2. So once you have your picture, you guys should be able to get your answers to those. Questions? All right. Again, let's stay focused. Let's keep our masks up, please. Some of you are getting a little lax in that department. All right, now, number 9, it says find the exact value, right? So it needs to be a fraction or in radical form. I don't want a decimal answer. That is not what I'm looking for. Okay? So this one is sine of 30 degrees plus cosine of 30. Okay? Tomorrow you might have a 45 in there. All right? So I'll draw both pictures that you're supposed to know. You're supposed to have this memorized. Okay? The 45-45 triangle, 1, 1, hypotenuse is square root of 2. For the 30, 60, 90, opposite the 30 is 1. The hypotenuse is 2. Opposite the 60 is the square root of 3. Just memorize those two triangles, and then you'll be able to figure out sine, cosine, whatever you need to figure out. It won't be anything different than 30, 60, or 45. Okay? So sine of 30. Remember, sine is so, right? Opposite over hypotenuse. So here's the 30. Opposite is 1. Hypotenuse is 2. So that's 1 over 2. Okay. Cosine of 30. We're still looking at the 30. Adjacent, right? Over hypotenuse. Radical 3 over 2. Since I have a common denominator, I can add those two fractions, right? And remember, it just, once you have the common denominator, it stays that denominator, right? And you just write 1 plus the square root of 3. You guys don't know what that is, decimal. You don't have to put it in the calculator. Just leave it like that. That's the exact answer. All right. It opens. It's always open. We always have people coming in late, right? Like you. All right. So I want the fraction answer. If there's radicals, leave the radicals. Simplify if you can the radicals. So that'll be the exact answer then. I don't want to see the decimal. The decimal is approximation, not exact. All right. So we got a 140-foot string attached to a kite. Stormy, you know what a kite looks like, don't you? Sometimes. Right? You guys ever fly any kite? That's an old time looking one. You guys might have had one that looked like Spider-Man. I'm trying to think. What little girl thing did you guys play? Barbie? Barbie? I think there was a picture of Barbie. All right. Maybe some trolls or something. I don't know. Yeah. All right. So, you guys hold this. It gets windy out. This time of year it's windy, and you get the strings to it, and go out in the field and let it go, right? So the string's attached down to you at the ground, right? That's the 140 feet. That's not down here on the ground for 140 feet, right? Does that make sense? Sure it does. Right? The string attached to a kite makes a 55-degree angle with the ground. So here's the ground, here's the 55. Okay? What is the height to the nearest 100? Height of the kite, right? So here's our little right triangle. We're looking for that height from the ground to where the kite is. Does that picture make sense? I saw some of you had the 140 down here. Okay? I saw some people had the 55 up here. Okay? That's not where the ground is, right? The ground's down here. All right, so just read it carefully. So, here's my theta, right? That's my reference point. We call it a reference angle, my point of reference. What's the X? Which side? Opposite, hypotenuse, or adjacent? That's opposite, right? 140, is that adjacent or hypotenuse? That's hypotenuse. So which trig function uses opposite and hypotenuse? Sine. So we're going to go sine of 55 equals opposite, which was the height, over hypotenuse, which was the 140 foot of string. Now you can use your calculator. Make sure your calculator is in what mode? Degree mode, because our angle is in degrees, right? So I always check that. So all I got to do is hit right next to second there, hit the mode button, and degree should be highlighted. If degree is not highlighted, just use your down arrow, move over, and then hit enter, so it's in the degree mode. If you got one like Maddie, down here on the right it says DEG. It's in degree mode for you. Okay? So I'm going to do what to both sides to solve it? Multiply by 140, right? Because you want that to go away, you want X alone, right? So we're going to go 140, you just hit sine, it knows it's multiplying. If you want to hit times, you can, you don't have to. 55, close it up, and that's 114.7. 0.68 if we go to the hundredth, like the directions say. Questions? This isn't that difficult, is it? You guys are going to do well. If you prepare, just take a few minutes to prepare. All right? Any questions at all? All right, that's all I got. Jagger? Yeah, 175 over 3, 420, right?
You want me to